Yeah, as I said, that the most important thing is the stellar evolution, and how the different stars would occupy this diagram. So this is the HR diagram, and the main sequence is here. And as a star evolves, it will move on this diagram. And below, you can see that different kind of stars will evolve differently. So the most important factor is the stellar mass and the time. Metallicity plays some role here, but not that critical. And here is another HR diagram. So you can see that, well, this is a HR diagram for M55. So 55 is probably it's an open cluster. So an open cluster means that the star, a cluster of stars, they all formed in the same time. So all of them form in the same time, almost the same time. And some of them are big and some of them are small. So that is called initial mass function. So you know that, well, you have a lot of small stars and you have some medium-sized stars, and then you have a little bit very big stars. And the big stars will evolve very fast, and they will move along here. It will move along the HR diagram, so it will move right. So you know that, well, these are very massive stars that have already evolved a lot. And all those here, they are still in the main sequence, and some of them have already passed the main sequence. And the turning point is very critical. The turning point will tell you the age of your car of the cluster. So you can determine that from here. Yeah. So yeah, so here, number one, you have 12 objects here that you need to know very detailed information. And for the physics behind that, you have some idea of the evolution of the star, and then you know how they orbit. So because stars, if you only have one star, then it's very simple. So it's just the evolve. But if you have multiple stars, it is a chaos, right? So that is another thing. But usually the most frequent case is that you have two stars, two different kind of stars. So they are rotating with each other. And then you know that there are some potential evolutions there. For example, the mass from one star could go to another star, or you have some frictions, so the two objects lose energies and it will get closer and closer, and it rotate faster and faster, and that is called a decaying object. And the different combinations of compact binaries, like different like novas, X-ray binaries, and neutrons binaries, and black hole binaries. So I may ask you, like, how to form black hole binaries, right? So you need to, after studying the details of this course, you should know that. Yeah, and in what situation you would have two neutron stars? In what situation you will have like two white dwarfs? So I think after study, you should know that. And number three is observations and classification systems of the post-main sequence stars. So all these would be based on the HR diagram. So the HR diagram is the key. So you try to invest a lot of time in understanding that diagram. So that basically carries everything. So for example, it will related to things like light curves. So light curves means that some stars get brighter and dim, brighter and dim, sometimes periodic, but sometimes not so periodic. But generally, anything that vary would give you a light curve. And all the 12 different objects here, so some of them show very typical light curves. So for example, like the R Lyra, so that is a variable star, that is a standard candle. Yeah. And a supernova, it had a very featured light curves, etc. Yeah. So and the number 4, and these like temperatures, luminosity, and mass. So all these physical parameters are very important because they will determine basically where you are located on that diagram. So what is the evolution stage, etc. And finally, is the scientific and engineering design for different telescopes. We can deep dive into different kind of telescopes. Basically, the wavelengths that you observe will determine what kind of telescope you are using. Yeah. So, yeah, later in this video, it will cover all these topics. Finally, is some some calculations. This is some calculations. So these are physics principles and some physical properties, and we can deep dive into them later. Okay. I'm finished. So any more questions? If no questions, then let's go to part 3.对，我现在就说。Okay, so do everyone knows who is your partner, or is your partner here or not? I think we have 7 in total. Yeah, so okay, Chloe, you know your partner. So we will have 3, I think 3 breakout rooms. Let's